Hello everyone. Today I am here with you all with one of the topic of class 8 maths curriculum, that is square and square roots. In this video we will be learning how to find the square and square roots of the given number, what all are the properties of the squares and some related questions about it. So let's start with the topic, that is your square and square roots. So first of all, let's understand what is a square. If a number is multiplied by itself, the product obtained is called square of that number. Like if I am going to take an example, suppose I am saying 2. If I am going to multiply this 2 by 2 itself, then we will be getting square of 2, that is your 4. Similarly, if I will be multiplying 3 by 3, that means number will be multiplied by itself, then we will be getting square of 3, that is your 9. If I'll be multiplying 4 by 4, we will be getting a square of 4, that is your 16. So whenever we are multiplying a number by itself, we are getting a square of that number, and that will be represented by your power could be your 2. It could even be written as power 2. Like if we have multiplied 2 by 2, we can write it as 2 raised to the power 2. If we have multiplied 3 by 3, we can write it as 3 raised to the power 2. Similarly, if we have multiplied 4 by 4, we can write it as 4 raised to the power 2. So, we will be getting the square of the number when we will be multiplying the number by itself. And whatsoever the number we are getting by multiplying any number by itself, these numbers are known as your perfect squares. Like over here, 4 is a perfect square. 9 is a perfect square, 16 is a perfect square. Similarly, I'll be multiplying 5 by 5, I'll be getting 25. So 25 will be a perfect square. All these numbers which we are getting by multiplying any number by itself, whatsoever the number we will be getting are known as your perfect square. All the natural numbers are not your perfect square. If I'll be multiplying 1 by 1, we will be getting 1. So 1 is even a perfect square. So 1 is a perfect square, then 4, then 9, then 16, then 25. All these are perfect squares, but the number which is coming in between these numbers, like your 2 is there, like your 3 is there, like 5, 6, 7, 8, all these numbers are not your perfect squares. So you must have understood what is your perfect square and how we can get the square of any of the number. If your number is positive, we can see the square will even be your positive. But if your number is negative, suppose I am saying your number is minus of 7. So square of minus of 7 we will be getting by multiplying minus 7 by your minus 7. So square of minus 7 will be your 7 is 49, because minus multiplied by minus will be a plus only. So whether your number is positive or your number is negative, square will always be positive only. If we have taken positive numbers, then also your square is coming positive, and if we will be taking your negative numbers, then also square will be coming positive only. Now let's understand some of the properties of your squares. For that, first of all, let's see the square of 1 to 10 numbers. Like just now we said square of 1 means 1 multiplied by 1, that is your 1. Square of 2 will be 2 multiplied by 2, that is 4. Similarly, square of 3 will be 3 multiplied by 3, that is 9. Square of 4 will be 16. Square of 5 will be 25. Similarly, square of 6 will be 36. Square of 7 will be 7 into 7, that is 49. Square of 8 will be 8 multiplied by 8, 8 is 64. The square of 9 will be 9 multiplied by 9, that is your 81. And the square of 10 will be 10 multiplied by 10, that is your 100. That all we can see over here, that how we can find the square of 1 to 10 numbers. So what we can conclude from here is, if the number is your odd number, say 1, 3, 5, 7, 9, then their square is even odd. That means for the odd numbers, squares are even odd. And for the even numbers like your 2, 4, 6, 8, 10, your squares are even your even. For odd numbers, squares are even odd, and for even numbers, squares are even. This is what we can conclude from here. Along with that, we can see if there is any number which is ending with your 1, either 1 or your 9. If number is having either 1 or 9 at its unit place, then the square will be having 1 at its unit place. If the number is having either 1 or 9 at its units place, then the square will be having your 1 at its unit place. Like example, we can take 11. A square of 11 will be your 121. If we will be taking 9, square of 9 is your 81. So whenever there is 1 or 9 at the unit place in the number, then the square of that number will be having 1 at its unit place. Similarly, we can see that if at units place number is either 2 or your 8. If at the unit place number is either 2 or 8, its square will be ending with your 4. If any of the number will be there which is having at its unit place either 2 or 8, then the square of these numbers will be ending with your 4. That means at unit place the number will be your 4. Like example, we can take 12. Square of 12 is your 144. So we can see in the number unit place is your 2 and square is ending with your 4. Similarly, we will be seeing if the number is ending with 3 or your 7. If the number is ending with 3 or 7, the square of the number will be ending with your 9. Like 3 is there. If we will be taking 13, 13 square is your 169 ending with your 9. If the number is having 3 at its unit place, the square will be ending with your 9. That means in the square unit place will be your 9. Similarly, if the number will be ending with 7, then also the unit place of the square number will be having your 9 at its unit place. Similarly, what we can see is if the number is ending with 5, that means at unit place if the number is 5, the square will even be having 5 at its unit place. Along with that, what we can see over here, if the number is ending with 4, either 4 or 6. If the unit place is either 4 or 6, then the square number will be ending with your 6. That means square will be having 6 at its unit place. So all the numbers we have taken 1, 2, 3, 4, 5, 6, 7, 8, 9. And similarly, if there is 0 at its unit place, if any of the number is having 0 at its unit place, then in the square there will be 2 zeros will be there at its unit place. If 1 0 is there in the number, then the square will be having 2 zeros. If there are 2 number of zeros are there in the unit place of the number, then square will be having 4 zeros. So we can say if the number of zeros in the number is your say n, then in the square we will be having 2n zeros will be there. Suppose I am going to talk about your say 200. If we have to find a square of 200, so it will be square of 2 is your 4, and because 2 zeros are there, so in the square there will be 4 zeros. Similarly, if we have to find square of say 3000, then square of 3 is your 9. Now because there are 3 zeros are there in the number, so in the square there will be 6 zeros will be there. So whatsoever the number of zeros are there in your number, in the square 2 times of the zeros will be there in the square. So all these are the properties which we can conclude from here. Now what else we can see over here? If number is ending with 1, 4, 5, 6, 9 and even number of zeros. Even number of zeros, if it is there in any of the square number. If any of the square number is either ending with 1, 4, 5, 6, 9 or even number of zeros, then it is possible that the given number will be square of any of the number. Like if I am going to say, suppose your number is say your 120, say 625. Say 625 is the number. So number is ending with your 5. So it is possible that this 625 is square of any of the number. But it is not always compulsory that if the number is ending with these numbers like your 1, 4, 5, 6 or 9. So always and always these numbers will be square of any of the number. Like if I am going to say 21. This number is ending with 1 but it is not a square of any of the number. Suppose I am going to say 34. This number is ending with 4 but it is not a square of any of the number. But it is possible that if any of the number is ending with 1, 4, 5, 6, 9, or even number of zeros, that these type of numbers could be square of any of the number. But if any of the number is ending with either 2, 3, 7 or 8, so directly by saying we can say that the given number is not a square of any of the number, not square of any of the number. Like if number is say 22, so at the unit place it is 2, so it is not possible that this number will be square of any of the number. We need not to check it even. Directly we can say that this number is not a square of any of the number. So all these are the properties of your squares. Now let's understand some more properties of squares. Adding triangular numbers. If we combine two consecutive triangular numbers, we get a square number. What triangular numbers are? First of all, we have taken 1. Then in 1 we will be adding 2. So this is your 3. Then in 3 we will be adding 3. So it is your 6. Then in 6 we will be adding 4. That is your 3 here, 1, 2, 3, 4. Total is your 10. Then in 10 we will be adding 5. That is your 15. In 15 we will be adding 6. That is 21. All these are your triangular numbers. If we will combine two consecutive triangular numbers, like if we will be adding 1 and 3, so we will be getting 4, which is a square of 2. If we will be adding 3 and 6, we will be getting 9, which is a square of 3. If we will be adding 6 and 10, we will be getting 16, which is a square of 4. If we will be adding 10 and 15, we will be getting 25, which is a square of 5. So what we can see over here is, if we combine two consecutive triangular numbers, we are getting a square number. Now the next is, a perfect square number leaves remainder 0 or 1 or dividing it by 3. If we are going to take any of the perfect square number and if we divide it by 3, either remainder will be 0 or it will be 1. Now let's check it. Suppose we have taken the number 4. It is a perfect square. So if we will be dividing 4 by 3, the remainder will be your 1. If we will be dividing 9, which is a perfect square number, by 3, the remainder will be 0. 3 3s are 9, so remainder will be 0. If we will be taking 16, which is a perfect square number, by 3, 3 5 is 15, so remainder will be 1. So whenever we are dividing any perfect square number by 3, either your remainder will be 0 or it will be 1. The next is numbers between consecutive square numbers. There are 2n non-perfect square numbers between squares of n and n plus 1. If we have taken two consecutive numbers, suppose we have taken say 3 and 4. These two are the consecutive numbers. Here n is your 3 and n plus 1 is your 4. These two consecutive numbers we have taken, and if we will be finding the non-perfect square number between square of these two numbers, that means square of 3 will be 9, square of 4 will be 16. So how many non-perfect square numbers are there between square of 3 and 4? It will be your 2n. n is 3, that means this will be 2 multiplied by 3. 6 non-perfect square numbers will be there between square of 3 and 4. Now let's check it out. Square of 3 is 9, square of 4 is 16. Between these two numbers, how many non-perfect square numbers are there? After 9 it is 10, 11, 12, 13, 14, 15. All these are the non-perfect square numbers. How many are there? 1, 2, 3, 4, 5, 6. So it is your 2n. Non-perfect square numbers are there between the squares of n and n plus 1. Similarly, if we will be taking n is equal to say 12. So n plus 1 will be 13. So between the squares of 12 and 13, the square of 12 is your 144 and the square of 13 is your 169. So between these, square of 12 and 13, that is 144 and 169, there will be 2n non-perfect square numbers. That means 2 multiplied by your 12. 24 non-perfect square numbers will be there between your 144 and 169. Adding odd numbers. Sum of first n odd numbers is your n square. So first odd number is your 1 only, starting with 1. First odd number is always 1 only. After 1, it is your 3, then it is 5, then it is your 7, then 9, then 11, then 13, like this. These are your odd numbers. If we will be adding first n odd numbers, like suppose we have taken only 1. So 1 is square of 1. If we will be taking 1 and 3, so 1 plus 3, 2 odd numbers we have taken, it is equivalent to 4, which is a square of 2, because 2 odd numbers we have taken, so it will be equivalent to your square of 2. If we will be taking 3 odd numbers, that is 1 plus 3 plus 5. So 3 plus 1 is 4, 4 plus 5 is your 9, that is a square of 3. That means if we have taken 3 odd numbers, the sum of these 3 odd numbers will be equivalent to a square of 3. If we will be taking say 1, 2, 3, 4, 5, 6 odd numbers, so sum of these will be square of 6, it will be your 36. We need not to add it, it will be equivalent to square of 6. So how many odd numbers we have taken, the sum of these odd numbers, which should start from 1 only, it will be equivalent to square of how many numbers you have taken. If we have taken 10 odd numbers, so sum will be equivalent to square of 10, that will be 100. For any natural number, n plus 1 square minus n square is sum of these two. That means if two consecutive numbers we will be taking, one is n, another is your n plus 1, and the square of these two consecutive numbers we have done. So difference between these two will be equivalent to sum of these two number, n plus 1 plus n. Suppose I am saying n plus 1 whole square, suppose I am saying it is 13 square minus of 12 square. So square, these 12 and 13, they are consecutive numbers, and square of these we have taken, and the difference between square of two consecutive numbers will be sum of these two numbers, that is 13 plus 12 it will be. That will be 25 will be the sum. The difference between 13 square and 12 square will be equivalent to sum of 13 and 12, that will be 25. We can check it over here even. Square of 12 is 144, square of 13 is 169. If we will be finding the difference of these two, 9 minus 4 is 5, 6 minus 4 is 2, it is your 25. Similarly, if I will be taking say 21 square minus 20 square, these 20 and 21, they are consecutive numbers, so square of 21 minus square of 20 will be equivalent to sum of 21 and 20, that is your 41. Just check it out. Square of 21 is your 441 and the square of 20 is your 400. Difference between these two is your 41. The next property is sum of consecutive natural number. A square of any odd number can be expressed as sum of two consecutive positive integers. If we are going to take any odd number and we will be squaring this odd number, then this square of odd number can be expressed as sum of two consecutive positive integers. Suppose I am taking square of 3. So square of 3 is your 9. So 9 could be written as 4 plus 5. Two consecutive numbers, two consecutive positive numbers we have taken, and we can write square of any odd number as the sum of two consecutive positive integer. Similarly, if instead of 3 we have taken 5, 5 is even an odd number. So square of 5 is your 25, and 25 could be written as 12 plus 13. Similarly, if I will be taking 7, the square of 7, 7 is your 49. So it could be written as your 24 plus your 25. Sum of 24 and 25 will be your 49. So this is how square of any odd number can be expressed as sum of two consecutive positive integers. Now let's understand some more properties of square numbers. Product of two consecutive even or odd natural numbers. If we are having two consecutive even numbers or two consecutive odd numbers, then product of these two numbers will be given by a plus 1 multiplied by a minus 1 will be your a square minus 1. Now let's understand it. Suppose your numbers are say 5 and 7. These two are the consecutive odd numbers. Now 7 could be written as your 6 plus 1 and 5 could be written as your 6 minus 1. If we have to multiply 5 and 7, then 7 could be written as 6 plus 1 and 5 could be written as your 6 minus 1. And if we are going to compare this with your a plus 1, a minus 1, we can see that value of a is your 6 over here. So product of these two will be equivalent to a square minus 1. That means 6 square minus 1. 36 minus 1, that is your 35. And we know that 5 7 is your 35. Similarly, we will be taking two consecutive your even numbers. Say we have taken 6 and 8. If we have to multiply these two, so we know that 8 could be written as your 7 plus 1 and 6 could be written as your 7 minus 1. So if we are going to compare this part with your a plus 1, a minus 1, we can see value of a is your 7. So product of these two will be your 7 square minus 1. 7 7 is your 49 minus 1, that is your 48, and we know 6 8 is your 48. So this is how we can find product of two consecutive even numbers or your odd numbers. Now some more patterns. If we know the square of 1 we know that it is your 1. So if we will be taking a square of 11, so two ones are there, so we will be increasing order from 1 to 2, then again decreasing order 2 to 1. Now square of 111, so three ones are there, so 1 2 3 up to 3 we will be moving in the ascending order, then descending order till 1. Similarly, if 4 ones are there, the square of this we have to find. So 1 2 3 4, then decreasing order 3 to 1. This is how we can find. This is a pattern. Similarly, one more pattern is there. Square of 7 we know it is 49. Then if it is a square of 67, then 1 6 is coming, so we will be taking 2 4s and 1 8 and 9. Like this we will be taking. Now if it is 6 6 7 square, so 2 6 are coming, so in the 2 6, so we will be taking 3 4s, 2 8 and 1 9. If 3 6 are coming and then 7 square, so 3 6 are coming, so we will be taking 4 4s and 3 8s and 1 9. So this is the pattern. Now square of natural numbers with 5 at its unit place. If there is any of the number which is having 5 at its unit place and we have to find the square of that, then how we can find it out? Suppose we have to find the square of 25. So what we will be doing is 5 5 is your 25 and it is 2. So we will be multiplying this 2 by the consecutive number, that is your 3. So 2 multiplied by 3 is your 6. 625 will be the answer. If we have to multiply 35 and 35, that means we have to find the square of 35. So 5 5 is 25. We will be multiplying 3 by the next number, next consecutive number, that is 4. So 3 multiplied by 4 will be your 12. So 1225 will be the answer. Similarly, if we have to find the square of 45, so 5 5 is 25. We will be multiplying 4 by the next number, that is your 5. 4 5 is 20. So this will be the answer. Now Pythagorean triplet. So Pythagorean triplet, we know that 2m, m square minus 1, m square plus 1 forms the Pythagorean triplet, where m is any natural number which is greater than your 1. So if m is greater than 1 and m is any of the natural number, then 2m, m square minus 1 and m square plus 1 will be forming the Pythagorean triplet. Now let's see, suppose I am taking m is equivalent to 2. Then 2m will be 2 multiplied by 2, that is your 4. M square minus 1 will be square of 2 minus 1, that is 4 minus 1, that is 3. M square plus 1. M square plus 1 will be your square of 2 plus 1, that is your 4 plus 1, that is 5. So 3, 4, 5 will be forming the Pythagorean triplet. What Pythagorean triplet is? Square of the biggest number, that is your 5. The square of 5 will be equivalent to sum of squares of rest two numbers, that is square of 3 plus square of 4. This is your Pythagoras theorem, that is hypotenuse square will be square of base plus square of perpendicular. Similarly, if I will be taking m is equivalent to 3, so 2m will be 2 multiplied by 3, that is your 6. M square minus 1 will be 3 square minus 1, that is your 9 minus 1, that is your 8. M square plus 1, that is 3 square plus 1. 9 plus 1, that is your 10. So 6, 8 and 10 will be forming the Pythagorean triplet. Now let's see what a square root is. The square root of a given number x is the number whose square is x. Suppose we have to find the square root of your 16. So what is the number by which we'll be multiplying the same number to get your 16? So if we know that 4 multiplied by 4 is your 16, that means square of 4 is 16. That's the reason square root of 16 will be your 4. The square root of a given number x, this is your x, is the number whose square is 6. So square root of 16 will be the number 4, because the square of 4 is your 16. So square root of a given number x is a number whose square is x. Suppose I am saying 25. If we have to find the square root of 25, so we know that the square of 5 is your 25. That's the reason square root of 25 will be your 5. So square root of any of the number will be the number whose square is your x, that is your 25. Similarly, if I'll be taking an example of 36, we know that the 36 could be written as your 6 multiplied by 6, or we can say square of 6 is your 36. So we'll be saying that square root of 36 will be your 6. The square root sign is this is the sign for finding the square root, which is known as your radical sign, and it simply means power as your 1 by 2. Suppose we have to find the square root of x. So this simply means x raised to the power 1 upon 2. Now, if we have to find, suppose, square root of 16. Now, how we can find it? How we can say that will be of 4? So, if we have to find the square root of 16, it means your 4 raised to the power 2, because 16 could be written as 4 raised to the power 2, and this radical sign means your power 1 upon 2. So we know that a raised to the power m whole raised to the power n is equal to a raised to the power m multiplied by n. Laws of exponents. So powers are going to multiply. 4 raised to the power 2 multiplied by 1 by 2, that is 4 raised to the power 1, or we can say 4 will be the square root of 16. Similarly, if we have to find the square root of say 81, so this means 81 raised to the power 1 upon 2. Radical sign means your power 1 upon 2. So 81 could be written as 9 into 9, or we can say 9 square. So 9 square raised to the power 1 upon 2. Powers are going to multiply. So 9 raised to the power 2 multiplied by 1 upon 2, or we can say the square root of 81 will be 9. So the square root of any of the number, given number x, will be the number whose square is x. So it is basically the reciprocal of your square only. Now let's understand how to find the square root of a given number. So finding a square root through repeated subtraction. So one of the method is through repeated subtraction we can find the square root of a given number. Suppose we have to find the square root of say 25. So what we will be doing is we will be subtracting the odd numbers from it. So first odd number is your 1. So in the first step we will be subtracting 1 from 25. So we will be getting 24. In the next step, we will be subtracting 3 from it. After 1, the next odd number is your 3. So we will be subtracting 3. We will be getting 21. In the third step, we will be subtracting the next odd number, that is your 5, from 21. So we will be getting your 16. In the fourth step, we will be subtracting from the 16. We will be subtracting your next odd number, that is your 7. So we will be getting 9. In the next step, we will be subtracting from 9 the next odd number, that is even 9. After 7, the next odd number is 9. So we will be subtracting 9. So we will be getting 0. So in how many steps we are getting result as your 0, or your difference is as 0? In 5 steps. So the square root of 25 is your 5. Square root of 25 will be your 5, because in 5 steps we are getting difference will be 0. So we will be saying that your square root of 25 is your 5. Similarly, suppose instead of 25, I am taking 36 as a number. We have to find the square root of 36. So in the first step, we will be subtracting 1 from it. So we will be getting 35. In the next step, we will be subtracting 3 from it. The next odd number will be 3. So we will be getting 32. In the next step, we will be subtracting 5 from it. So we will be getting 27. In the next step, 27 minus 7 we will be doing. That will be 20. In the next step, 20 minus 9, that is your 11. And in the next step, 11 minus next to 9 odd number will be your 11 only. It will be 0. So in 6 steps, our difference is coming equivalent to 0. So square root of 36 will be 6. This is one of the method. The another method is finding square root through prime factorization. So what we will be doing in prime factorization, suppose we have to find the square root of 225. So what we will be doing is, first of all, we will be doing the prime factorization of 225. Now, first of all, what we can say is 5 to 7 and 2, 9. Sum of 225 is 9. So it is divisible by 3. So first of all, we will divide it by 3. 3, 7 is 21 and 3, 5 is 15. So we have divided 225 by 3. Now again, we will be dividing this 75 by 3. We will be getting 3 2s are 6 and 3 5 is 15. 25 is divisible by 5. So we will be dividing it by 5. 5 5 is 25 and 5 1 is 5. So prime factorization of 225 is your 3 multiplied by 3 multiplied by 5 multiplied by 5. So we have written 225 as the product of your prime numbers. Now what we will be doing is, we will be making pair of all the prime numbers. From this one pair, we will be taking 1 3 out. From this pair of 5, we will be taking 1 5 out. So 3 multiplied by 5 is your 15. So square root of 225 is your 15. Similarly, if we have to find, suppose your square root of 2025. So what we will be doing is, again we will be doing the prime factorization. First of all, 5 to 7, 7 and 2, 9. So again it will be divisible by 3. So 3, 6 is 18. Then remainder will be 2, 22, 3, 7 is 21 and 3, 5 is 15. Again we will be dividing it by 3. So 3 2s are 6. 3 2s are 6, 3 5 is 15. Then again divisible by 3, it is 225, so it will come your 75. Again dividing it by 3, it will be your 3 2s are 6, 3 5 is 15. Dividing it by 5, 5 5 is 25 and 5 1. So the prime factorization of 2025 is your 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5 and 5. So what we will be doing, again we will be making pairs of all the prime factors. From one pair we will take 1 3 out. From here also we will take 1 3 out. From here also we will take 1 5 out. So 3 3s are 9 and 5 9 is your 45. So we will be saying that square root of 2025 is your 45. This is how by prime factorization we can find the square root of the given number. Now suppose your number is not a perfect square. Suppose I am saying 250 we are taking. Now by what number we should multiply this 250 so that it will become a perfect square? For that what we will be doing is, first of all we will be finding the prime factorization. It is divisible by 2. So 2 1 is 2. 2 2s are 4 and 2 5 is 15. Now it is divisible by 5. 5 2s are 10. 5 5 is 25. Then again by 5. 5 5 is 25. Again by 5. It is your 1. Now the prime factorization of 250 is 2 multiplied by 5 multiplied by 5 multiplied by 5. Now we can see over here that there is no pair of 2. Only a single 2 is there. This is in pair. This 5 is in pair. But again this 5 is even not in pair. So if we will multiply this by your 2 multiplied by 5. So 2 will be having a pair and 5 will even have a pair. So if we will multiply 250 by your 2 multiplied by 5, that is your 10, the new number will become a perfect square. Whatsoever the numbers are not in pair, we will be making it in pair so that it will become a perfect square. Here single 2 was there, single 5 was there. These two 5s are in pair, so we won't touch it. Now because it is not in pair, it is not in pair. If we will multiply it by one more 2, these two will have one pair. If we will multiply it by 5, these two 5s will even have a pair. So if we will multiply this 250 by 10, we will be getting your 2500, which will be a perfect square of 50. Similarly, if instead of multiplication the question says by what number it should be divided so that it become a perfect square, in that case what we will be doing, again see over here, 250 could be written as 2 into 5 into 5 into 5. Again the same procedure we will be doing, the same prime factorization we will be doing. Now see over here, this is having a pair. Now this 2 is extra and this 5 is even extra. If we will divide this 250 by this 2 and this 5, if we will divide it by this 2 and this 5, then what it will be the remaining? That is your 5 into 5, which is already in pair, so it will be a perfect square. So if we will divide 250 by 2 into 5, that is your 10, the result will be a perfect square. That means if the question says by what number it is to be multiplied or by what number it is to be divided, your answer will be same. By same number we will be multiplying it even to become, so that the number will become a perfect square, and we will be dividing it even by the same number so that the resultant number will become a perfect square. If we will be multiplying it 250 by 10, it will become 2500, which will be the square root of 2500 will be your 50. And if we will divide this 250 by 10, then it will become 25, and square root of 25 is your 5, right? So if it is to be multiplied or to be divided, in both the cases, whatsoever the numbers are your unpaired, just multiply all those numbers, and if you will be dividing or multiplying the given number by that number, you will be getting a number which will be a perfect square. So this is how, by your repeated subtraction and through prime factorization, we can find the square root of a given number. There is one more method of finding the square root of a given number. If your numbers are very big or if your numbers are not a perfect square, then we can use your division method also. We are already having a video on how to find the square root of the number by division method. So you can watch that video so that it will be clear to you how to find your square root by division method and how to solve related problems to it. This is all from this chapter. Soon we'll be coming with the more videos on other chapters of class 8 maths curriculum. Thank you.